Is the speed of light truly unbreakable? Or could the opposite be true, hidden in plain sight, protected by the very dogmas we refuse to question? Modern physics treats 299,792 kilometers per second not just as a measurement, but as something sacred, a hard ceiling written into the very fabric of reality itself. Your textbooks present this figure with absolute certainty, your professors teach it as fundamental law, and your astronomers use it to calculate the age and size of the observable universe. But here is the uncomfortable truth that history keeps trying to teach you. Every generation mistakes its current limits for eternal laws. In the early 1900s, the sound barrier was considered an absolute physical impossibility. The most respected aeronautical engineers produced complex mathematical proofs showing that an aircraft would experience catastrophic structural failure before reaching the speed of sound. The air itself, they argued, would become an impenetrable wall. It was settled science. And then, on October 14th, 1947, Chuck Yeager climbed into the Bell X-1 and flew straight through that supposedly impenetrable wall. What shattered was not the plane, but the assumptions of an entire generation who had confused their incomplete models with ultimate truth. Today, we stand before another wall. The speed of light is treated not as a measurement, but as a cosmic commandment. Anyone who questions it risks being dismissed as a pseudoscientist. But what if this limit tells us more about our tools than about the universe itself? Consider what is already happening within your own accepted science. Quantum entanglement allows particles to remain mysteriously connected across arbitrary distances. Change the state of one particle, and its entangled partner responds instantly, regardless of the space between them. Your physicists carefully say this doesn't transmit information faster than light, because admitting otherwise would shatter their entire theoretical framework. But the phenomenon itself remains deeply strange. Gravity presents another puzzle. It shapes entire galaxies across distances so vast they break intuition. And then there are your GPS satellites. Every day, billions of people use positioning systems that contain a quiet anomaly. An anomaly that engineers compensate for, but rarely discuss in public. Because discussing it might lead to uncomfortable questions about whether light speed is truly constant in all reference frames, not fringe theories. These are observable phenomena within mainstream physics. They are the cracks in the wall. So perhaps the real question isn't whether something can break the light barrier. Perhaps the question is, are we measuring the true nature of the universe, or simply the resistance of the medium we move through? The story begins in 1676. A Danish astronomer named Ole Christensen Rockmer was observing the moons of Jupiter through his telescope. He noticed something strange. When Earth was moving away from Jupiter in its orbit, the eclipses of Jupiter's moon Io appeared to happen later than predicted. When Earth was moving toward Jupiter, the eclipses appeared earlier. Rockmer made a brilliant deduction. Light must have a finite speed. The delay occurred because light from Jupiter had to travel a greater distance when Earth was farther away. His calculation was remarkably accurate. This was a triumph. One of the first times humanity reached out across the solar system and extracted a universal constant. But here's the deeper question that no one asked. Did Rockmer measure the fundamental nature of light itself? Or did he measure the time it takes for a signal to struggle through an invisible resistance? This distinction is foundational. Imagine you are running on a dry track. You can reach a certain maximum speed. But now imagine running through a pool of water. Your speed collapses. Not because your muscles became weaker, but because the environment changed. If you had never experienced running on dry land, you would conclude that your maximum speed in water was a fundamental law of your biology. You would be right within your context, but profoundly wrong about the deeper truth. For centuries, the greatest intellects understood this principle. Isaac Newton suspected the existence of an invisible substance pervading all of space. James Clerk Maxwell, whose electromagnetic equations form the foundation of all modern technology, built his entire theory on the assumption of a supporting medium. He called it the luminiferous ether. Auguste Jean Fresnel treated light as a wave, and waves require something to wave in. This was mainstream scientific consensus. They saw the cosmos not as a cold, dead vacuum, but as a living, energetic ocean. The ether was not mysticism. It was logical necessity, because how could a wave exist without a medium? Sound needs air. Ocean waves need water. The wave requires the medium. Then came 1887. Albert Michelson and Edward Morley designed what they believed would be the definitive test for the ether's existence. If Earth was moving through this invisible ocean, there should be an ether wind, a detectable current. Their interferometer split a beam of light and sent it in perpendicular directions. If Earth was moving through the ether, Light traveling against the ether wind should move slightly slower. The beams would show an interference pattern that would shift as the apparatus rotated. They measured carefully. They repeated their measurements at different times of year, trying to catch Earth at different angles. And their result was unambiguous. There was no detectable ether wind. The interference pattern did not shift. And with that, an entire model of the universe was discarded. This is a story about a choice made at a crossroads in science that shaped the world we live in today. It begins with a failed experiment, an experiment that sent shockwaves through the scientific community. The goal was to detect the ether, a supposed invisible ocean that filled all of space, the medium through which light was thought to travel. But the experiment found nothing. At this critical moment, science could have asked if the experiment was sensitive enough, or if their assumptions were incomplete. But instead, they made the boldest move imaginable. They declared that the ocean does not exist at all. Space was redefined as a perfect absolute void, and light, unlike every other wave we know, would travel through this nothingness without any medium to support it. Think about how radical this is. Sound needs air. Ocean waves need water, but light was declared the single exception. To make this new worldview work, a new law was created. The speed of light must be constant for all observers, everywhere, always. This principle is the foundation of Einstein's relativity, leading to its famous consequences like time dilation and length contraction. And relativity works. It makes predictions confirm to astonishing precision. GPS satellites, particle accelerators, all of it confirms Einstein's theory. But was it the only possible interpretation, or just the most convenient? Because an empty universe is simple, described by clean equations. An ocean is complex, filled with currents, energy, and possibility. And possibility is much harder to control. Now, let's talk about something uncomfortable, the technology inside every smartphone that suggests the official story might be incomplete. It's called the Sagnac effect. GPS relies on satellites sending precisely timed signals to calculate your position. This requires phenomenal precision, down to billionths of a second. According to pure relativity, since the speed of light is constant, the timing should work perfectly with just relativistic corrections. But it doesn't. Engineers discovered they needed an additional correction for the Sagnac effect, which compensates for the Earth's rotation. Without this fix, GPS would be off by several kilometers every single day. This effect, first shown in 1913, demonstrates that a light beam traveling with rotation takes slightly longer than one traveling against it. This shouldn't happen if light speed is truly constant for all observers. The Sagnac effect suggests the existence of a preferred reference frame, a background structure that light moves through. If there's no ether, what exactly is the Earth rotating relative? The engineers don't worry about the philosophy. They just apply the corrections. But the fact these corrections are necessary suggests something profound. Space is not nothing. Now we turn to the most controversial figure in this story, Nikola Tesla. So much myth surrounds him. But the documented facts are extraordinary enough. He pioneered the AC systems that power our world and laid the groundwork for wireless communication. But Tesla believed something that put him at odds with modern physics. He insisted space was not empty. He rejected Einstein's relativity and believed the universe was filled with a physical medium, an ether, that could be used. His most ambitious project was Wardenclyffe Tower, intended not just for wireless communication, but for the wireless transmission of electrical power. He envisioned a global system where energy could be broadcast through the Earth and atmosphere, accessible to anyone. No power lines, no meters, no central control. If it worked, it would have been the most disruptive technology in history. But Wardenclyffe was never completed. Tesla ran out of money. His main backer, J.P. Morgan, pulled his funding. In 1917, the tower was demolished. The popular myth says Tesla was deliberately suppressed because of the threat of free energy. But the simpler truth is tragic enough. He was too far ahead of his time. His ideas were expensive and impossible to monetize with existing business models. But here's where it gets scientifically interesting. Tesla claimed to have discovered a different kind of wave, one that moves through the ether itself, not bound by the speed of light. Mainstream physics doesn't accept this. But the question remains, was Tesla just wrong? Or was he exploring a genuine phenomenon that was never properly investigated because it fell outside the accepted paradigm? We can't know for sure. His notes were scattered, his lab gone. The official story is that government scientists reviewed his papers and found nothing of value. Perhaps some ideas were simply too destabilizing to explore. Tesla left behind a sentence that still resonates today. If you want to find the secrets of the universe, think in terms of energy, frequency, and vibration. This isn't mysticism. It's physics. Everything in existence oscillates. Atoms vibrate. Electromagnetic fields fluctuate. The entire universe hums with energy, resonating at every conceivable scale. But what if the electromagnetic spectrum as we know it isn't the complete picture? Imagine a vast cosmic keyboard. What if there are keys, frequencies that we haven't yet learned how to play, or even to hear? What if the transverse electromagnetic waves we're so familiar with are just one mode of energy, and there are other fundamentally different ways for that energy to travel through the very fabric of space? Tesla seemed to believe this. Whether he was right or wrong, the question he posed was profound, and it was never truly answered. Now, we arrive at a fascinating irony. Modern physics has long insisted that the ether, a hypothetical medium filling all of space, doesn't exist. That Einstein proved space is a perfect vacuum. And yet, if you ask a physicist today to describe that vacuum, what they tell you sounds remarkably like an ocean. Empty space, it turns out, isn't empty at all. It's seized with activity. Quantum field theory describes our reality as a collection of fields that extend through all of space. There are electron fields, photon fields, and quark fields. And these fields are never still. Even in a total absence of particles, the fields themselves fluctuate. Virtual particles, pairs of matter and antimatter, pop into existence and annihilate each other in an instant. These quantum fluctuations have real, measurable effects. They cause something called the Casimir effect, where two uncharged metal plates in a vacuum are pushed together by an invisible force. Why? Because the quantum fields between the plates are restricted, while the fields outside are not, creating a pressure difference from the vacuum itself. The vacuum also possesses an enormous amount of energy. When physicists tried to calculate the energy density of empty space, they got a number so large it was absurd 10 to the power of 120 times larger than what we actually observe. This is known as the vacuum catastrophe, one of the biggest mysteries in theoretical physics. But despite this puzzle, the fact remains. The vacuum is not nothing. It's structured, dynamic, and incredibly energetic. It has properties. It can carry waves. The vacuum is an ocean. Physicists just use different words. Quantum fields, vacuum fluctuations, zero-point energy. But the picture is the same. Space is filled with something, and that something has energy that could, in principle, be kept. Now consider the greatest mystery in cosmology, dark matter. We see galaxies rotating in ways that make no sense based on the visible matter within them. Stars on the outer edges are moving far too fast. Something with mass, with gravity, must be holding them together. Something we simply cannot see. Dark matter makes up 85% of all matter in the universe. Everything we know, everything we are, is just a tiny 15%. And we have no idea what dark matter is. Physicists have proposed exotic new particles, and massive experiments are searching for them, but so far, nothing definitive has been found. But what if dark matter isn't a new particle at all? What if it's the ether itself, the invisible ocean declared non-existent over a century ago? It would be invisible because it doesn't interact with light in the conventional way. It would have gravity because it has mass energy. It would fill all of space because it asterisk the structure of space. If this medium exists, its gravitational pull would explain the rotation of galaxies and the large-scale structure of the universe. Why do physicists call it dark? Perhaps because their tools are designed to detect light. If something doesn't interact electromagnetically, it's dark by definition. Not absent, but vibrating in ways our instruments can't perceive. If 85% of the universe is invisible to you, you're only seeing the foam on the surface and calling it the ocean. The deep currents, the vast bulk of what exists, remain hidden right here, all around us. And then there are black holes. Textbooks describe them as cosmic graveyards, regions where gravity is so strong that nothing, not even light, can escape. This picture is true, but it might be incomplete. We know black holes are real. We've detected their gravitational waves and even photographed their shadow. But if light itself cannot escape, what does that truly tell us? The standard answer is that the escape velocity exceeds the speed of light. But consider an alternative. What if the inability of light to escape is evidence of how incredibly dense the underlying medium, the ether, becomes in these extreme conditions? Imagine it compressed to near infinite density. Light would struggle and fail to propagate outward, not because of a cosmic speed limit, but because the medium itself has become too thick to travel through. In this view, a black hole isn't a graveyard, but an extreme density point in the universal ocean. A place where the currents become so powerful that our familiar physics no longer applies. Not an end, but a transition. This opens a fascinating possibility that black holes might be connected to white holes. A white hole is the time reverse of a black hole. Nothing can enter a white hole, matter and energy spoil. If they are connected, what enters a black hole might not be destroyed. It might be expelled somewhere else, in a different part of the universe. This is speculative, but the math of general relativity allows for it. If true, black holes are not endpoints but cosmic portals. The universe would be a closed system, its energy conserved, the ocean flowing in grand eternal cycles. And in that case, the speed of light looks less like a universal law and more like a local condition, property of the shallow waters where we happen to live. So we return to the beginning. Is the speed of light truly unbreakable? Or is it simply the fastest ripple on the surface of a deeper sea? From everything we have examined, from the historical accident of the Michelson Morley experiment, to the constant corrections required by our GPS systems, to Tesla's unfinished work, a pattern emerges. The walls we perceive are not physical. They are conceptual. They are definitions, assumptions, interpretations chosen at a particular moment and then elevated to absolute truth. Relativity is a brilliant theory. It works. Its predictions are confirmed time and time again. But brilliance does not equal completeness. Every era in history has made this mistake. Every generation has mistaken its current ceiling for the sky. In ancient times, people believed Earth was the center of the universe. The evidence seemed overwhelming. When Copernicus suggested Earth moved, he was ridiculed. But he was right. In the 19th century, the sound barrier seemed absolute. And then we flew right through it. What was once a wall became routine. Perhaps, from the perspective of the future, our era will be seen as the time when humanity was trapped by the speed of light. Not because the universe demanded it, but because we believed it. Because we built our physics around an interpretation that declared the ocean imaginary. Because we confused a local property with a universal law. The light speed barrier is made of assumptions. And assumptions can always be questioned. The ether was never disproven. It was simply declared unnecessary and then forgotten. But necessity is not the same as truth. Quantum mechanics and general relativity are both incredibly successful, yet they are fundamentally incompatible. Physicists have tried to unify them for a century. All their approaches suggest that space-time itself is not fundamental, that there is something deeper, a substrate, a structure, an ocean beneath the waves. What if that ocean is what Tesla called the ether? What if it's what cosmologists call dark matter? What if 85% of the universe is invisible, not because it's exotic, but because it's right here, all around us, vibrating in frequencies our instruments cannot yet detect? From the future, we might look back at our 21st century with admiration for its achievements. We split the atom, we decoded the genome, we built thinking machines, but we might also see the limits we accepted. The walls built in our own lines. The prison constructed from constants we were told were unshakable. The key to escaping the Lightspeed prison isn't hidden in some secret laboratory. It's in our willingness to question. To ask whether the limit is real or just a property of our current understanding. To look at the cracks in our theories and wonder if they hint at something more. We were never truly trapped by light speed, only by the belief that it was the final horizon. The ocean was always there. The universe was never empty. Space is not nothing. It is full, energetic, structured, alive with possibilities we have barely begun to explore. So here is the final question. Will we continue to accept the limits we were taught? Will we keep burning fossil fuels and declaring the stars forever unreachable? Or are we ready to wonder if we're born for the waves? The ocean is waiting. It has always been waiting. The journey is just beginning. We have a choice. We can remain on the beach, watching the horizon, accepting the vast distances as permanent. Or we can dive in, feel the currents, learn to swim in the deep, discover that the resistance we thought was absolute is just the friction of incomplete understanding. From the future, we can tell you, the walls will fall. Not through a single breakthrough, but through accumulated questions. Through experiments that probe the medium rather than denying its existence. The Lightspeed prison will open. Not because physics will change, but because we will finally understand what those laws were really telling us all along. Greetings from the 22nd century. We have learned to swim in the deep. We have reached the stars by understanding the flow. We no longer look at light speed as a barrier, but as a surface condition. We have found the deeper currents. We have tapped the ocean. And we are waiting for you to join us in the infinite. The choice has always been yours. Dive in. The water is fine. Thank you for watching. If these ideas sparked your curiosity, consider subscribing for more journeys beyond the known.